Hi, so again, I'm Zach Smith. I'm a professional service engineer. I've worked with a few of you in the audience, deployed R10K at a few of your shops actually. This is a workshop, but we're gonna level set to make sure that everyone's basically on the same page of what we're talking about first. Prior to that though, you should probably start downloading the link, given conference and internet and that kind of thing. Might as well start cloning now. As well as probably, if you don't already have a gem install R10K running, might do it as well while we're going through these slides. All right, so this is a beginner's workshop to talk about basically R10K. We'll definitely have time for questions at the end, but to make sure that everyone has a basic understanding of what you would use or deploy this particular configuration utility for. The general concept is that you as the system administrator are likely developing Puppet code on your laptop, and you probably, if you're a relatively good system administrator, have some kind of version control or repository system where you're actually going to need to send that code. And I'm going to apologize now because I really like build slides, so there's going to be some really cheesy ones coming up. The Git repository here is not really your Puppet master, though. The Puppet master is going to have to actually somehow get that code onto it. And so in a very simple way of thinking about R10K is it's the middleman between your Puppet master and that Git repository. So the Ruby gem is actually going to install on your Puppet master, and typically you're going to be pulling down from that Git repository. So we'll come back to a little bit more detailed example of this in a second. All right, so in the case of a Git repository, a fundamental concept that you should understand about R10K and the way it works is it's based on dynamic environments. And dynamic environments or directory environments are basically the concept that you have a series of subfolders on your master which corresponds to environments that Puppet can use, okay? Now, in a Git repository, you're gonna have a series of likely branches of code. You might have a production branch, a testing branch, and a development branch. So in a way, all R10K is basically going to be doing is the middleman operation of the Git repository will take these Git branches and turn them into subfolders of a given directory, which is where your module path is, okay? Now, normally if you're using Git, of course, you're going to check out your code and it's going to be the same folder. So we're going to do these in parallel effectively on the same directory so that each one of them can be used to compile a catalog. The advantage of this is that your production environment can have a different version of the module that you're using than your development environment. This is just kind of a basic slide. There likely to be another folder in the mix here, but just as a concept, likely your production environment is going to have the oldest code, right? It's going to be the oldest thing that you've been developing. Your development environment, however, is going to have the newest code that you have, right? What you can do with this is with Puppet, you can actually have a set of servers that are maybe your development servers or testing or QA. In addition to that, on your production servers, you might actually want to test to see what would happen if we were going to deploy development code on a production environment rather than, oh, I don't know, testing in production. Probably not a good idea to do that. So on the Puppet agent side of things, environments are set up a variety of different ways in Puppet, but one of the more common ways is in Puppet.conf on the agent, I can specify an environment. The way this is actually implemented in Puppet, if you don't know, is it's basically every single time we go to 8140, we're requesting a URL. And that prefix for that URL is the environment. So it's that one thing that we always know when we're compiling a catalog, because it's going to hit Puppet, the master, using development as that prefix on the URL. So when the master detects this, it knows to look based on the module path for the development folder and compile the catalog from the code within that folder. So we can have something like the development module for Apache, which is likely a copy, as it were, of all these other environments, but just with newer or older code. So again, on each individual agent, we can set this. Now, in Puppet, you don't, as a slight aside, have to do this on the agent side. If you have a node classifier, you can actually specify the environment as a top-level key. That top-level key is a little bit more secure than doing it on the agent side if you're using this as a security mechanism where you don't want your development code and your production code to actually be mixing. In other words, If you had a development machine and you ran Puppet in the production environment, you might get the production passwords downloaded to the development machine. Probably not the thing you want to do. In the case of doing this in Puppet.conf, it's happening on the agent side, so if somebody's got root, they can actually go in and change it. Doing it with a node classifier is authoritative, meaning that you can actually specify this in a much more central manner. The node classifier, instead of having Puppet.conf settings on the agent, would actually specify this at the time of classification when the node checked in. So you could say, when this node checks in based on some kind of logic, maybe the Puppet Enterprise console or a script that you wrote yourself, I'm going to tell that machine that it's a development machine. And I can do that based on a variety of different information, such as its node name, potentially its fax, and a few other things like that. All right, as your Puppet environments grow, if you have a Git repository, you might have a big monolithic repository full of all of your modules. And the problem with that is over time, if you've got a large number of administrators, you likely are going to be merging code into that from a variety of different people. And that may account for things like merge conflicts. It's also harder to break things out and test them independently when you've got this big monolithic repo of all the modules in just a subfolder. So R10K doesn't require you not to use a monolithic repo. It's kind of a common misconception. You can use monolithic repos with R10K, but it does have a functionality that most people, as they move forward with R10K, slowly transition to the Puppet file. Now, some people just start with the Puppet file. And the Puppet file is a way of basically going in and pulling additional repositories. So I, for instance, can have an internal Git repo where I have a module that is basically being maintained perhaps by a team, the Tomcat team, the Memcached team, the Cassandra team, and they can do whatever development workflow they want. I, as the system administrator, can manage the Puppet file within that development branch, and that allows me to basically, if I want, pin it to a particular reference point. Now, in this case, this is like a SHA-1 hash. However, you could also do something like a Git tag to make it a little more human readable if your module developers out there are using Git tags. Outside of that, if I'm working on a branch, development, if you imagine having to update the tag every single time, it becomes kind of a double commit. Those of you who used Git submodules, it's a similar kind of paradigm to that. But in this case, if you don't want to track a particular revision of the code, you can actually tell R10K also to track a particular branch of that code, meaning your development, what we call control repo, typically, so the thing that's actually version controlling the Puppet file, will actually be told that the internal Git repository for the module is going to have a development branch itself. And we can always, as R10K runs, pull in changes from that development branch, meaning I don't have to double commit every single time. Now, even if you don't have module repos, one of the more common things also that you're going to use Puppet files for is the fact that we have a forge, right? And so when we look at things like the Java module, some people with monolithic repos may go and download the Java module from the forge, go run a git add, install it, and then of course the problem is that you don't really own that code. So as you actually go and try and get new versions of it, you're basically going to have one gigantic commit for all the individual history commits and things like that of the forge or external module from your repository. So in a simple paradigm, you can actually use Puppetfile to just download forge modules, and it can be a list of forge modules within its DSL that basically tell you a particular namespace and a particular version. And similar to the monolithic kind of example earlier, you could then, of course, have different versions or the same, right? You don't have to have different versions between the branches, but the idea is that this allows your development environment to have perhaps a newer or older version of the code. All right, so a little bit more commonly when you look at this, we had the idea that you're going to write some code, but of course you're going to actually write some code and then you're going to run a git push. So from your laptop, when you git push, if you had something like a feature branch, which is pretty common, I might, on my local repository, check out a feature branch of my code because I want to make some changes to the Puppet code, and I don't want to push that to production. I may not even want to push it to development yet. I just want to see what would happen if I were to, say, refactor this or use a different module or use a different version of the module. So I'm going to take that feature branch, and I'm going to push that up just using standard git to my Git repository. Now, once it gets there, the idea is that it somehow needs to tell the master, in a way, that there was a new thing that was added to the Git repository. This is often pretty easy to do. Most Git repositories either have a concept of a post-receive hook or they have web hooks, and so you can use a Git hook. And so the Git hook here will trigger when you do a Git push to the repository, right? So the Git hook basically could be, in many instances, in things like GitHub Enterprise or Stash, an actual web service that's going to go out and make a call, and that call will include things like the branch which was pushed to. And this gives R10K a little bit of information in a more common environment to say, oh, you just pushed a new feature branch. I should probably go and synchronize it. So that hook gets sent over to R10K. Did you like that? It's awesome, right? Yeah.
You spent a lot of time on these slide animations.
I know. Yeah, he wrote a markdown to shell script generator. I made this happen. So basically what's happening behind the scenes is R10K is then going to do a Git pull, right? So it's just an automation routine so that when the hook is received by that, R10K is going to do a Git pull. That branch is then sent over or pulled down into a repository, which is cached, which is one of the nice features of it. And it's going to be converted to the folders that we saw earlier. Okay? So it's going to unspool it on disk, if you will. Now, one nice thing I like about this, being a professional service engineer, is this also, in the paradigm of multiple data centers and multiple different masters, you could have this happen on all of your masters. So now you have a centralized control point in your Git repository, which then will synchronize your code out. Now, some people do this with NFS. Some people have like a push methodology with Jenkins. I'm a bigger fan of this because it actually is Git, and so you're doing incremental downloads or pulls effectively on all of your masters. And if you need to troubleshoot something, all these repositories actually exist on the master. And so you can go back and look through things like the history and do Git checkouts locally, all that. So it's not like you're pushing with Bamboo with a SCP or something and copying it over as just an artifact. All right, so once the actual environment ends up on the master, or in this case, it's a branch, but it becomes a Puppet environment as a subfolder, the Puppet agent can then actually do a run against this, not necessarily with the puppet.conf entry, but using the command line, right? So you can specify -- environment and tell it to use this new feature branch. So that tells the master to compile the catalog against that subfolder versus the one that was originally in its puppet.conf. Now, this is probably not exactly what you would do in production. Generally, you might do something like this, which is -- environment new feature with a no-op flag. So what this allows you to do is simulate what would have happened if I were to apply this code. Now, if you're running a 20,000-line Perl script with Puppet, simulation isn't going to get you much. But if you've actually taken a large amount of your code out of your Perl script and turned it into resources which themselves can be idempotent and simulated, then simulation is going to do a lot for you. And so this paradigm allows you to create a new feature branch and simulate in production maybe at 455 before you're actually going to go and push the change into production. What would actually happen according to Puppet in a simulated manner before I made this change? So in this case, you would, if you're managing a file, you would actually see the diff of the file, and you'd see, oh, man, we forgot to set the variable. And I never saw it in the CI tests or anything else because it just didn't really become apparent until the machine itself compiled a catalog and attempted to apply it even in a simulation mode. Things like Hyra, for instance, are hard to test without something like this sometimes. All right, so no changes would actually be made to the file, just to be clear. It is simulation or no operation mode. And this new feature branch could then go away after you merged it into development or whatever your specific series of branches that you probably keep around rather than these branches that you're going to leave. All right, so hopefully that gives you a base idea of what R10K does if you've never heard of it before and gets you start thinking about what we can do. This is a workshop, however. So the link that we sent out earlier is a set of instructions which you can go and do yourself. So when you leave here, it's non-root. As long as you have Git, R10K, and Puppet, you can actually walk through these yourself, get familiar with it. But right now, Adrien is actually going to go ahead and use my Mac, which is a scary thing because he runs Linux on his laptop, and go through this. There you go.
And one quick shout out. So if you're interested in hearing more about this, or you're interested in the very, very nice hook animation that we saw earlier, we're going to see there is another Puppet talk scheduled for R10K. I think it's like 5 or 6 by Phil Zimmerman. Definitely check it out.
Yeah, his is going to be much cooler than ours. Just compare that there. Yeah.
All right, shall we start? Yeah, so with respect to this demo, as many of you might know, the demo gods tend to be merciless, and in fact, we actually had a brief network outage a few moments ago, so a lot of this is offline. The entire thing, though, is pretty well documented, so if you want to run through this after the fact, go home and show a coworker or something like that, you can go through everything shown here, you can reproduce elsewhere, but if you want to follow through during the lab, please do so.
So just to be clear, this is my Mac. We're not running root here, right? We're just going to run Puppet locally.
Yeah, so what we're going to do is, just to keep your environment a little bit cleaner, we're going to create this R10K workshop directory. We're going to throw some things into it. So to start off, we're going to make a source directory for all of our the code that we're going to be editing, a Git directory, which is going to emulate some remote Git server, and then the Puppet directory is going to be where we're actually going to deploy our environments. Your turn.
Yep, all right. So we're going to create a bare repo here. In this case, this is likely your actual Git repository, whatever it's GitHub Enterprise, it's Stash, something like that. This is a local one. If you don't have a Git repository yet, you could always do this stuff locally as well, just to start with.
Yeah, this does give us the workflow, though. You do some work, you push a change on your with R10K on your master, you pull it and things like that. This is pretty common, so we're going to try to emulate that common workflow as much as we can. And once we have that repository created, like we had above, we can just do, we can go into that source directory, clone that empty repository, and then we can go into it and start doing interesting things. So to start off with, we are going to create an environment.conf. Actually, just for my curiosity, who is using a version of like Puppet 3.4 or below? Okay. 3.5? Okay, move to 3.6. Who's using 3.6? Excellent, and 3.7? Yes, you guys are awesome, thank you. So we're going to be using a new feature of Puppet 3.6 and above called directory environments, which makes it a lot easier to do the dynamic environments approach. So you will need a more modern version of that, and so what we're doing here is with Puppet 3.6 and above, we can now configure your module path, your manifest, your config version on a per environment basis. It used to be global, but now you have much more fine-grained control.
In other words, environments are now first-class citizens, which is kind of awesome.
Yeah, the future. So yeah, to start off, we're just going to create this environment.conf with some very basic content. We're going to add it, commit it, pretty straightforward stuff. Actually, we probably jumped ahead. Who here has worked with Git in some basic fashion? Okay.
Good.
Brilliant. I love you guys. Who has not used Git? Okay, cool. It's very cool, but it's also a little bit scary. So, who uses SVN? It's okay. Okay. So R10K, we accept you. I accept you. R10K
we're an accepting community here, so.
R10K does support SVN. There are a couple caveats. You have to use tags, trunks, and branches, and it's going to be slow. You cannot make SVN fast, but it still does work quite well. So we do actually have some options like that, and we may be adding more version control systems in the future. So in the meantime, though, we're just going to do the standard git commit and push. And we're also doing right here this git branch. By default, the Git branch that is created by default is master, but it's kind of an arbitrary name, and to get a nice one-to-one relationship between our Puppet environments and our Git branches, we just rename it, and so generally makes life pretty easily, or much easier. The next thing we're going to do is we're just going to create a very simple module using the Puppet module generate, and I think that was added in like 3.6 or something like that. So we run it, and it goes through and fills out some answers, and let's run through what we actually did. So we created a new site directory. That's where we are going to be putting our modules.
And site's an arbitrary name there.
Yeah,
it's the default in the README, but it could be anything. I've made it like customer names before. Yeah. It's just the subfolder that's within the repository, to be clear.
So site-specific modules, MicroCorp modules, and so forth. So create a module. We just need our directory. We just need a place to put it. Create a nice, very cool module called Hello World. You get major points if you see where the ash pool reference came from. And we're just going to make a very simple class that's just going to do notify for Hello World. And we've pushed it, and so we should be able to, we're going to make a very simple site.pp to do the same thing, to actually include it. Otherwise, we're not doing a lot. And I managed to scroll down. Fantastic. The next thing we need to do is configure R10K to know where to pull our code from. And apparently, I forgot how to highlight. Cool. So what we're doing here is we are going to create the r10k.yaml, which is going to say we are going to have some sources for environments. And this one is going to be called control. And the directory we're going to copy them into is the current directory /environments, so R10K workshop Puppet environments. And it's going to get that code from the remote, which is the R10K workshop get environments.get.
Yeah, and if I can chime in here for just a second, something to consider in this is that it's a remote for Git, right? So likely it's going to be something like an SSH remote. That means you're likely going to have keys you're deploying on your masters to actually allow for this to happen. In this case, it's local, so there's no authentication actually needed, right?
And the next thing we need to do is to make Puppet apply work with our alternate directory is we just need to, yeah, so I use Linux a lot, and I keep forgetting the key binding. So
awesome.
We're going to set up a puppet.conf for our current user, non-root user. So yeah, if you are doing this as root, you'll notice right here, we are setting this up in the local puppet.conf directory. If you're doing it as root, make sure you have the environment path pointed to wherever you want your environments to be.
And so this is one of the new features. Previously, you would do this with $environment, and you would basically have it be a stand-in for those subfolder names, right?
It was a dirty hack. It was a dirty, dirty hack.
It's a clever, dirty hack.
It was great. Yeah, no, it was actually a couple of guys and I sitting around like, wow, we really like Git, and we want to use dynamic environments. I wonder if oh, wow, this variable is interpolated. And then many years down the road, I moved into the development team. They said, oh, you're the guy who discovered that. We hate you. You're a monster. All right, so now we have gone from having nothing at all to having a Git repository. We've made a module, we've made changes, and now with R10K deploy, we have said, grab that Git repository, find all the branches, and create a branch or a Puppet environment for each branch. So if we do find on the environments directory, we'll see, aside from other things, Git, cool. We have our hello world module, and we have our environment.conf. So fantastic. So let's just try running this code and see what happens. It might remove your root file system. Cool. All right. So we did hello world. So if we do cat environments, production, site, tab, manifests, init.pp, this is exactly what we added.
Yeah, and so don't get confused with site and site.pp. They don't really have anything to do with each other. Site's just an arbitrary name where we're keeping the hello world module in this case, right?
All right, so we've made a change. Let's try rolling something out, rolling some new changes out. So we're in the production environment. Let's just grab our hello world module and hack it up so that instead of saying hello world, let's say what environment we're in this case, production. So it is so much easier to do copy and paste because otherwise I'd be up here making typos at like an incredible rate. We're going to make those changes and push them. And so if we do git log-p, we can see that I said update the hello world module to print the environment, and here is our change right here. And so if we scroll down correctly, and once again, by default, if we do R10K deploy environment, it will not log anything because the default log level is warned. So if you see nothing happens, nothing broke. But if we do -v, we can see some informational messages. And we can see what's going on. If we do -v debug 2, this means you will see everything ever that happened. So if you're ever you're working with R10K and something strange happened, debug 2 will tell you things about the world you didn't want to know. But it'll help debug, yes.
And it's running Git underneath the hood, right? So that's a great one for if you have a problem, likely you can just simulate it by running the same commands that R10K is running, because it's often not R10K that's the issue. I mean, sometimes it is, but then he fixes it. Yeah. And then when it's not, it's typically some problem with actually Git. And so you're just going to troubleshoot it using that standard command.
OK, so we've done the whole workflow. We've made some changes to Git, our Git modules. We've pushed them, and now we've deployed them with R10K. So let's see what changes we've made. And so if we do cat environments, production, et cetera, we will see the new message is I am in the production environment. So yay, we've pushed changes. And if we apply them again, you will get exactly what you expect. Cool. And so who here is familiar with Git branching or has used Git branching to a fair degree?
OK, and now I'm going to tell them we can't make them raise their hands anymore.
OK.
Because I hate raising my hand.
I like it. I like audience participation.
We'll just make them nod.
OK. Enthusiastic nodding. So the next thing we're going to do is we're just going to make a branch. So the big thing about R10K is that you can create an environment whenever you need it just by doing a git checkout-b. So if we do these first two commands right here, we will now be able to, if we push this branch, we will now have an ashpool test branch, or ashpool test environment as well. So let's just grab this. And so in this case, we're going to change from a hard-coded environment that we had earlier to this variable interpolated value. So once again, paste it in. If you do git log-p, we can see the diff is, instead of hard-coded production, we do variable interpolation. So once again, change directories, deploy.
And just to talk about this for a second, so the hook joke earlier, right? This is all the hook is actually doing. It's going to parse out the branch and basically run this command behind the scenes.
Yeah. Yeah, this does get a little bit repetitious after a while, but there's a lot of moving parts, or there could be a lot of moving parts, so we're doing this just for clarity. So if we do cat right here, so we did a bunch of things. So we did ls environments in the Puppet environments directory, and we now see the ashpool test directory and the production directory. And so if we do ls in the ashpool test directory, see kind of the same files. But if we display the init.pp as we modified, we will see that it's been updated. And in addition, once again, the production environment has not changed at all. It's isolated. Your production servers do not care that this change happened. They will never see it. But if you have some development machines that you want to do some testing on, those ones will see the update. And once again, if we do the Puppet apply, the environment variable right here, it's the environment variable, not like an environment variable, but an environment variable. Note how I phrased that. Yeah, so right here, inside of your Puppet manifest, you're able to determine which environment you're currently using. So now we can do this dynamically. So we will see the message is I am in the ashpool test, or I think we're clipping. Oh well. Let's just say that says ashpool test. So now we can do interesting stuff based on the environment in your catalogs. And so instead of hard coding, you can do a lot of interesting stuff.
Yeah, and I'm just going to stop there for a second and say that R10K does technically support more than one remote as well. So if you have two different groups, you might actually have two different Git repositories. In that case, they might both have a development branch, and you can have an arbitrary prefix added to each one of these individual groups, which you can do some pretty clever multi-tenant stuff with if you want to.
OK, so we've made some changes in this very snazzy lookup of the environment variable. We want to do this, bring this into production. So this could be in your development environment, you rolled out some changes. Now you want to try them or bring them into production. This is just Git workflow, nothing magic. So we say, let's go to the environments repo. I really need to stop jumping ahead so quickly. So go to our environments directory. Check out the production branch, and let's just say merge the ashpool test directory. And we can see that we made some changes. And once again, I just push because I can. And so if we do a git log-p -graph, unfortunately, I did a fast forward. Oh well. So we can see that we now, in the production directory, have this updated hello world module with our fancy new change. So, oh, actually, we do even have a section on automating R10K. Cool. So when you go through back through this, and when you're bored or want to show all your coworkers, you can read that section and be enlightened. And once again, deploy. We kick some changes out. Let's just see that we're in the production environment, that we have the changes we want. Yay! Seriously, so much better than typing. And if we do a Puppet apply, we will automatically pick up that the environment is now production. So fantastic.
What's that?
How much time do you want to do? Questions?
Yeah, we'll do questions.
All right. Well, let's continue doing cleanup. So let's say so in some situations, we may actually want to have a long-running dev branch that we're just going to have applying to some machines. But if you are standing up machines in a dynamic manner, or you throw machines away, or if you're saying, let's do a no-op run on a production system, you may actually have these branches that last for a very short period of time, then you delete them. So in order to make things nice and snappy, we delete branches that we do not need. So one of the nice things about R10K is that it actually can handle degenerate situations where, let's say you have a few hundred or so branches. This is not ideal, it gets slow. So with R10K, it can continue running in a pretty graceful manner. So, but do delete your branches when you're done.
Please.
Yeah. Do you want to hop into Puppetfile stuff?
Yeah. So is there any questions so far? We got about 10 minutes, and we figured there'd be quite a few in this session. So, Eric?
So I think one of the challenges that we're running into is versioning the control repository and tracking that back to what's being applied by Puppet. I mean, it's very straightforward with R10K, I think, from the perspective of the Puppetfile and the dependent modules, because the control repo, I think, is a pretty critical question.
So the statement or question is kind of versioning the control repo. Yeah. I always yell and ask Adrien. I don't yell. And I say, oh, can we use tags for this, for instance? And tags are immutable in Git, and so they're not really great for that particular thing. Some people do try to use config version, but it doesn't necessarily have the support for things like Hyra. When you add changes in your control repo to Hyra, it's not necessarily going to change. If you're not familiar with config version, it's the small variable that ends up at the very end of your log. That's typically the second since epoch. You can actually change that to run a script, and that script can actually go and tell you the revision of a given Git ref, for instance, as well. So yeah, it's definitely a little tricky. It is an idea that the Puppet file, or the control repo, as we like to say, the repo that's controlling that Puppet file, is a particular set of modules at any given time. And so it itself is, though, a repo. So you could actually tag an overarching version. That version 1 is these 7 different versions. It's just not going to have an exact way of kind of tracking that within Puppet right now until things like config version are better.
In addition, I've been looking into incorporating some sort of way to deploy tags. They do have some interesting implications, but let's talk afterwards so we can address a few more questions. But very happy to talk more. So, next question, yeah.
So we don't use Git on the masters because Git tends to be more fragile than Subversion for locally modified files, and ends up blocking the entire poll instead of just one particular thing if there's a change that collides. Is there something you do? So we're actually using rsync pushes to prevent any kind of local editing on the masters. Is there something you do with our R10K that kind of solves for that? Like if I run into a conflict, I just blow it away, or
Inflict beatings on all your staff until they stop modifying code in production. So it's actually, I mean, here's the thing.
We're not using Git.
Yeah.
It makes that we just do a push with rsync.
We can do things like we could do a forcible reset and things like that, but I do take the stance currently that, I mean, modifying like code on a live system, that can be tremendously dangerous. I mean, there is this really lovely little program called Bumblebee that they made it was for graphics drivers. And this guy made a mistake. He did rm-r, for the uninstall, he did rm-r/user//lib. And deleted the entire user file system. It's a typo, but I mean, those are scary, and so R10K could be modified to wipe the working directory and things like that, because changes should not persist in a live system, but generally, modifying systems in a live manner like that is scary, and I would say, and beatings are pretty easy to administer too, so.
Well, yeah, but I mean, that was one of the reasons, that was the benefit
Yeah.
of just listening to using Git, was modifying
Yeah.
it on the phone.
To briefly touch on the point of deploying code, it's possible. I've been working on this as well. Right now we support Git and SVN. I'm interested in making the whole source layer pluggable. So you could use rsync as a source. You could use an S3 bucket as a source. Interpretive dance perhaps, but I haven't worked out like the libraries needed for that. So yeah.
Cool. There's somebody in the back there. Yep. Yep, you.
I was wondering about moving from the monolithic repo for all your modules to separate repos, and how you would work with that in the Puppetfile initially,
Sure.
and then transition essentially.
So the question was, how do you transition from a monolithic repo over to a Puppet file? I mean, the nice thing about the Puppet file is it's just a file that you create in your monolithic repo. And so at the end of the day, you can actually slowly migrate things. If you've got somebody who's Git savvy on your team, my main thing is that they should probably migrate the history, because you can prune it down to that specific dir and then create a new actual repo from there. But you can individually do it. The idea of the site directory in these examples, Site is a directory that exists in the main repository, but the Puppetfile is actually going to create a directory called modules by default. That's actually why we had to set up the environment.conf to tell it that there would be multiple module paths in the mix here. Now, in that case, what it really means is that you have two module paths, and so as you migrate from the monolithic over to the Puppetfile, you're just kind of pulling it out of one and putting it in the other, and production or anything else shouldn't really matter as long as the code that you pulled out is the same thing that you've pinned it to in the Puppetfile as you do it. Cool. Let's do, I'm going to do some of the back since they raised their hands too. Yep. Yeah, Adam. Yeah.
So in the example you showed, you can do a dash environment to run, do a Puppet run against an alternate environment. How does that change with the new PE that was announced where, since the environment's authoritative in the new node classifier, can I still run against an alternate environment in the node?
So the ENC has always been authoritative, but if you didn't have an ENC, it just wasn't that opinionated. So the new ENC actually has basically a bypass or defer or a let the agent choose mode. So there are many cases where you actually say, no, this node will always be production and no one ever gets to pick at it, in which case you can enforce that. But there is a mode where the agent can request an environment. So it does still work. Like I said, I've caused a lot of trouble in this whole R10K business.
You're using Puppetfile, test it out, and then you want to deploy it to Puppet masters.
In the same manner that we were doing here, you can just do or deploy the code locally, do a Puppet apply relative to that, and would you like to?
Oh no, I was just going to repeat the question. So yeah, what's the difference between the workshop and kind of what you do in production? Is that kind of a gist of it?
Well, today in production we're using Git pulls and Puppet masters.
Well, I mean, it's just doing get polls behind the scenes.
Yeah.
So if you've got, if you don't use the branching, I mean, something to understand is you don't have to use the branching aspect of this.
If you use branching, I guess what I'm asking, it has to set up the folder for the environments on Puppet. So you have
Your module path has to be changed under Puppet Master if you don't already have it looking for, dollar environment. So. Yep.
I guess that's what I'm asking. What sets up the folder when you get the folder? I guess that's the way the repository is set up?
R10K will build up, or I think it.
That's what I'm missing. So R10K is going to be installed on Puppet masters?
Yes.
And on your local developer?
Yes. Yeah.
Actually, so I'm going to guess. Yeah.
Just a question around, I know this workshop is all about R10K, but have you seen any customer using other than R10K for the code deployments?
Yeah, I mean, before we had this, we deployed a bunch of shell scripts at clients. And so the question was, have we seen anything else other than R10K?
But is there any tools available in the market other than R10K?
Oh, there's Puppet Librarian and
Librarian solves the
Henson's not
yeah.
quite built yet, too,
Yeah.
I think. Yeah.
There's Puppet Librarian, which implements the, that's where I stole the Puppetfile idea from. So there's that, but it just says, given a Puppetfile, install those modules. So there's nothing to my knowledge that says, given a source of environments, make them on disk. So there might be one.
I've only ever seen SSH scripts, basically.
As an APE professional service or agent, would you recommend if you have any requirements to support with UDeploy?
Sorry, what?
UDeploy,
Oh.
an IBM product.
Yeah, no, I know you deploy. We should probably talk afterwards, actually. So, all right.
In my environment, I use Git push to our Puppet masters.
Oh, they're the repositories themselves?
Right.
Okay.
So is it possible if they have R10K run on an intermediary host that can then do Git push to the Puppet master?
R10K fundamentally has to run on, are you pushing to like Etsy Puppet environments? Or?
I'm actually doing a sync to a local repository of Puppet master, and then I have a post to it, like a post receive file.
So that basically is how R10K works.
Yeah,
So
R10
I might say that it's going to do pretty much parity with that, and you could maybe replace it in that regard.
So,
Just for security purposes, we don't allow Git pulls from the Puppet master back to our.
oh, in that sense.
Oh, okay. I mean, it can always have a remote. I mean, that is the
Yeah,
local.
yeah.
Sure.
Yeah, change the Puppet file to point to local
Yeah,
files on
any
disk.
Git remote will work. And then the question was basically, what if we want to have the repository live on the master? And we are just about out of time, so
Wait,
thank
oh,
you
and now we're out of time.
all.
Sorry. Oh, we can talk afterwards, so we'll be around.
Yep.
All right, thank you.